Now we have antiderivative rules. Just like we have rules for differentiation, we have rules for integration. Similar to derivative rules, if we have a constant, we can take it outside of the integral. Same as what we did with derivatives. This is also the same with derivatives. If I have a function plus or minus another function, if I take the derivative, I can take the derivative of each individually. I can do the same thing with integration. The integral power rule is the opposite of the derivative power rule. With the derivative power rule, I would subtract 1 from n and multiply by n. For integration, we add 1 and divide by n plus 1. Exponential, e to the x equals e to the x. Derivative and integrals are the same. When we try to take the derivative of some base to a power, we multiply by ln of a. Here, we divide by that. The derivative of ln of x is 1 over x. The integral of 1 over x is ln of x. How would I solve this integral? So I can start using my rules. First thing I'm going to do is I'm going to take this constant outside of the integral sign. Now the integral of e to the x is e to the x. So this is equal to 5 e to the x, and I'm going to evaluate it between 0 and 3. This becomes 5 e to the third minus e to the 0, which is equal to 5 e to the third power minus 5. Or you could say, or from here, you can say 5 times e to the third minus 1. Either way, both the same. I use the first rule, and I use the exponential rule. Here, I'm going to use a couple of rules. First, I'm going to use the sum and difference. I can say this is equal to the integral of 2x dx. Now, this dx refers to both of these, plus the integral of e to the x dx. And this would be sum and difference rule. Now, I can take the constant outside of the integral, and this is the constant rule. And then I could say this is 2. Now, this is the power rule, which says I take x to the n plus 1 divided by n plus 1, plus the integral of e to the x is e to the x. My 2's will cancel, and I end up with x squared plus e to the x power. Now, if you look, you'll notice that I do not have a product. I have a constant, some difference. I have a power rule. I have exponential. I have natural log, but I don't have multiplication. So that means what I have to do is first, I'm going to FOIL this. So I have the integral from 0 to 2 of x squared minus 4x plus 3x minus 12 dx, which equals the integral from 0 to 2 of x squared minus x minus 12 dx. I can separate these into separate integrals, or I can just say this is x to the third power rule minus x squared over 2 power rule minus 12x. And why am I not adding my plus c? Let's just do it. I'll show you why. And I'm going to evaluate this from 0 to 2. Start with 2. I plug in 2 for all my x's, and I get 8 over 3 minus 4 over 2 minus 24 plus c minus, when I plug in 0, everything goes to 0 but the c. And notice the C cancels with the C, which is why I don't need the C. This equals 8/3 minus 2 minus 24, which equals 8/3 is 2 2/3 minus 2 minus 24 is minus 23 1/3, or 0.3333. I can't use any product rule here. I just multiply it and then use the power. Now this looks like it would be division, but again, it's not. We don't have a rule for division for integration. So I have to figure out how to make this work. I can say this is equal to the integral from 4 to 9, and I'm going to separate this first into two separate fractions. We have the integral from 4 to 9 of 4x squared over x to the 1/2 power dx plus the integral from 4 to 9 of 3 over x to the 1/2 power dx. I'm going to use my constant rule to take the 4 outside the integral, which means I have x squared divided by x to the 1/2, and that gives me x to the 2 minus 1/2. 4 halves minus 1/2 is 3/2 power dx, plus the integral from 4 to 9 of 3x to the minus 1/2 dx. And from here, I just use my power rule. This is equal to 4 times x to the 3/2 plus 1, which would give me 5/2 divided by 5/2, evaluated between 4 and 9, plus 3 times x to the 1/2 power divided by 1/2, evaluated between 4 and 9. First, we're going to simplify. This is 4x to the 5/2 power, and then divided by 5/2, it's the same as times 2/5. This we have to evaluate between 4 and 9, plus 3x to the 1/2 power times 2, evaluated between 4 and 9, which equals, I'm going to multiply the constants together. I have 8/5 x to the 5/2, 6x to the 1/2, evaluate between 4 and 9. This is equal to 8/5 times 9 to the 5/2 minus 4 to the 5/2. First I put in the top value, then I put in the bottom value, and then I have plus 6 times 9 to the 1/2 power minus 4 to the 1/2 power. Now, how do I evaluate 9 to the 5/2 power? 5 to the 9/2 power is the same as 9 to the 4/2 power times 9 to the 1/2 power, because I add exponents. B to the m times b to the n equals b to the m plus n. That means this is 9 squared times the square root of 9, which is equal to 81 times 3, which is equal to 243. Minus, and again we have the same thing. We have 4 to the 4/2 times 4 to the 1/2, which equals 4 squared times the square root of 4, which equals 16 times 2, which is equal to 32. Plus 6 times, this equals 8/5 times 211, plus 6 times 1, which is 6, which equals 343.6. And that would be my final answer. Thank you for watching, and I'll see you next time.